Okay, the assignment we are going to do is the image manipulation. All right. Uh, just like Instagram uses or any other image package like Photoshop. Okay, any image editing tool uses this kind of algorithms that we are going to implement. Okay, algorithms, and we are going to implement in C, and I'm going to teach one or two. Okay, I will teach one or two, and the rest you guys can figure this out or do um, in your leisure time, either as a hobby or something like that. But this assignment that we are going to do, it is very simple. Okay, and I'm going to show you what it is. Okay, first you need to install. There's a file called a package called GIMP in Windows World. Windows or Mac you can use. Okay, so you need to install tool GIMP. It's open source. Okay, and install this either on Windows or Mac. That's the very first thing. Second thing is, if you are using your own laptop, all right, and you might have to go back and use FTP, file transfer protocol, or the SPS, whatever we did in the uh, beginning of the course. I think it isn't it. Remind me. I think we did something like. If I go back, I think it is PSFTP. Let me just check what we did. Yeah, PSFTP. We did PSFTP, right? So let's go back here. So we have to use that PSFTP like we did in the beginning of the course, right? So transfer files. Why we have to transfer files, I'll show you in a second, all right? Okay. Okay. So this is about the image. So install or use this tool and a GIMP. You have to install two things. All right. Okay. And make a video of this, or sorry, screenshot of this, and make a note of it. Okay. Next step. I have already written the program. The program is, you have a file, you have a picture. Let's say you have a picture. I'll just put a smiley face. Okay. Unfortunately, this picture is not JPEG, not GIF or BMP, whatever it is, because these files are in binary and it's very difficult to read in our course. I will not be able to teach you that. But so I had to find a simpler method. Okay, so the simpler format is, we will not teach that, is that PPM or PGM. Okay, portable gray map, portable grayscale and or PPM. This is a portable PixMap. What this is color, and this is black and white grayscale. Okay, just like black and white movies. So the only tool, image processing tool, that opens these files is this GIMP. Right? And these files are raw files. The raw file means, I will show you in a second here. If you see it, okay, do you see that? Each is a pixel value written in clear text, less like ASCII text, or this is a pixel value 68. 26 means, okay, the pixel values, the another thing you need to make a note here, ranges from 0 to 255. That means 256 colors, 0 to 255. So when you say 256 colors, what does it mean? That means we can store that in 1 byte. Right? That's what this, because this is written in ASCII, these are not written in 1 byte, they are written in 2 bytes. 1 for 6, 1 for 8 in this case. And here it's 3 bytes, 102. 102, there are 3 bytes, which is not a very efficient way to store, but because you guys have to understand the concept of pictures, I have used this format. Okay, the beginning of the form of the picture, the header, is nothing but, this means P2 means PGM, this is a comment, and this is the width, this is the height, and the maximum pixel value in the file. So this is a standard for every file picture. This thing changes, the width and the height, right? But we are going to keep it 99 and 99, width and height. All right. So far you have, if you have any questions, let me know. You install GIMP. Go ahead and figure out if you still using PSFTP, because we can't view our pictures in our Linux system. So you need, if you're using our Linux system, you have to go back and forth. That's why you have to use this PSFTP. But if you are using your laptop to run your C programs, then you don't need to use this. Okay. Number 3 is, we are going to use the PGM format, and you guys don't have to know much about this. Okay. Number 4 is, I also talked about pixel values. Pixel is 0 to 255 a pixel, right, which is 1 byte in general. All right, and let's talk about the pictures. Pictures are nothing but, let me take a simple example. Alright. So we have, how many pixels we have? 1, 2, 3, 4, 5, 6 and 24 pixels we have, right? We have 24 pixels in this picture. 4 rows and 6 columns. And I am taking this as an example, but in the program that you guys are going to write, it has 99 width, pixels width, and 99 pixels height. But for discussions, I'm just taking a simpler example. Alright. Okay. Each and every individual pixel is stored in this file, the .pgm. Okay. And you can read that in the file here, like I said. You see, 66, 56, 48. These are arranged in column wise first, and then next rows, and the next row, and next row, like that. For instance, this is the first pixel, second, third, 4, 5, 6. So in the file, the actual data is stored, the value of this pixel first, the value of the second pixel, the value of the third pixel, value of the fourth pixel. I'm talking about the values, not these numbers, okay? The values of the pixel, like we talked here, it ranges from 0 to 255. And let's see if there is any 0 to 255 here. We don't have 0 maximum. So what is 0? What is 255? 0 is black and 255 is the white color, dark and white. And that's why we use in all the image tools. I hope you get that. Okay. If you don't get it, read some Wikipedia or something like that on about pictures. So I hope you guys know it. So then 5, 6, then the next 7th pixel, the value is stored here. The value can range anywhere from 0 to 255. So that's why it's stored 8, 9, blah 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 till 23 for this picture. Okay. Alright. Now again, pause the video and understand how these are stored. Now let's talk about our program. I have written the program for you, a C program. Okay. Let me write it bigger. And this is your file, image file. Okay. This is in .pgm file. And our program allocates a buffer, a two-dimensional buffer. Okay. It's just an array, two-dimensional array. We talked about 2D array, right? We read this entire file of data, just the pixels, into this buffer. So first step is read the pixel data or image data into the buffer. All right, that's first step. In the very first program, what we are going to do is we are going to copy this buffer. This is the input buffer, okay? Input buffer. We are going to copy the input buffer. When we say buffer, it's just a memory. In our case, it's a 2D, right? 2D array. We are going to copy into this another 2D array called output buffer. You can call it as anything you want, all right? It is just a variable of 2D. How do you declare 2D? Output buffer equal, like that. In our case is 99, right? 1 dimension, 2 dimension, right? All right, so we are going to copy. So we got the same data that we read from the file, and then the last step is to write to the file, to another file. Okay, read the data into the input buffer, copy, and output. So this is how image tools work. Okay, they use buffers inside, copying from one to out. Now I am going to show you the program, how it's done, so you get a picture. And in this assignment, all right, in this assignment, you are given these routines to write to the file. Okay, it's all given to you, so you don't have to worry about how to write to a file, at least not in the next couple of weeks. Maybe after a couple of weeks we'll try to learn how to do it, but you can always look into the code to see how it's done. Okay, this is given to you, all right, and this is also given to you. How to read is also given to you. How to read into the buffer, how to take a buffer to a file. All you got to do is these operations. There are many operations called image operations or image processing. Okay, this is how they are done. They take the buffer, do something, and copy into the output buffer, and then you write to the file. All right, and believe it or not, all the satellite processing of pictures, spy satellites, missiles, tracking of objects, environment, pollution, everything is done in this operation. And you guys are going to do one or two, all right, processing. We will only do processing. We will not do analysis. If you guys do analysis, probably you can get a job in CIA, FBI. Okay, these are intelligent programs. to track objects, to track everything from submarines, spy satellites, all that. But for now, what we are going to do is just copy. This, believe me, this itself will take a couple of days for you guys to understand how this program works. So spend time, all right? And what I'm going to do now is give me a second. I have to do something here. Okay. So I'm going to show you the program now. But remember, I have copied to a PowerPoint, so you can always look into the PowerPoint of this particular slide. All right. Okay. I'm going to erase this. So idea is you copy from a file into the buffer, and you do some kind of operation on the buffer and write to the output buffer. All right. The operations could be copy, inverse, scale, rotation, mirror image. You can do lot of stuff on the operations. The very first thing we are going to do is just simple copy. We're going to take the buffer, plug it into the output buffer, and you already have routines to write to the file. Okay. This is input file. The picture is given to you, so you don't have to worry to the output file. And when you are done, in case you are using the Linux system, you can FTP this file and view it in your GIMP tool. Okay, I'll show you in a minute. Okay, let's go back to the file. Enough of talking, right? Okay, so we saw this is the picture, different kind of picture pixels, right? These are different pixels. I'm going to show you the how we copy. Okay. All right. This is the input buffer. If you see it, unsigned char, pixel array. I could have named it as input array. Okay. Let's name it as input array for now. And the width and height, in our case, is 99. By the way, to define constants, we use as define. All right. So as define is one way to define constants. In our case, width 99 means you can use w as a constant variable whose value is always 99. All right. Okay, let's go back. This is the header which all PGM files need, but you don't have to worry about this at all. I have taken care of that for you. And I have opened the file input PGM, which we are talking about, this input file. I have taken care of that too for you guys. So I'll read the file. I'm opening the output file too, because if a program wants to run, I need to open the output file too. So I'm doing this as a very first step. Open the input file, open the output file. Here is what I'm reading from the file. You don't have to worry. Like I hear input array, right? I somehow read into my input array. If you want to pay attention to that, figure this out. But this is not needed at this moment. We're not interested in how to read pictures in this course. We are only interested in processing pictures using two-dimensional arrays. So it comes out into here. Now what do I have to do? I'm copying. I'm done here. In this part of the code, I am read the file and copied into my buffer. Okay, don't worry about it. How do I copy? I just copying from the one array to the another array. Here it is. You have a 2D array. Let's pretend it's a 2D array, and you have another array. They have to be identical, okay? So I'm reading first pixel, copying into the first pixel here. I'm reading the second pixel, copying into here. Third pixel, copying into here. Fourth pixel, copying into here. That's what I do. Read each and every pixel from the input array to the output array. That's what I'm doing. How do I doing? In a for loop. I equal to 0, I less than width, I plus plus, for ij equal to 0, j less than height, j plus plus, input array, it's a 2D, right? It's a two-dimensional data. That's it. A plain copy. Alright. Okay, this part is the copying. I've copied into the buffer. Now I need to write to the file. This is what I've done. Each and everything. So you don't have to worry about this portion. So the only place where you have to worry is this. Alright. So I'm going to remove this file, remove this code, particular 3 lines of code. I want you to guys write it and get experience. Just you know what, I'll just leave it, leave as it is. Okay, I'm going to compile it. Don't worry about warnings. My input is PGM. By the way, I'm running in our Linux system. I can't view this picture in our Linux system. So what I have done is I have this PSFTP, somewhere I have it. There we go. I'm going to show you guys here. Open cs.sierracollege.edu. I'm going to get that file input.pgm to show you what the picture looks like. Oops, I need to fall 2014 C. Get. Right. Now I have this file somewhere in my system called input.pgm. There you go, input.pgm. This guy gets, the GIMP opens this file. Nobody on earth opens this file, so I am waiting for it to load. Something it says invalid file. Okay, I just loaded here. So this is the input file. If this is the picture that we have, okay, a simple picture that has a stop sign, right? Now I'm going to run my file and gcc copy, right? Okay, what is my file, output file? My output file is, let me call it as copy. So I ran my program, it copied into copy.pgm. Alright. Now I have to bring it to my laptop, copy.pgm, and it's somewhere in my system, copy.pgm. See, there it is. See here, it copied. So I just copied. So how did I do it? The very first thing is step 1. I'm going to upload this program in the canvas. You guys read it and run through this program. Let me know how you guys do it. Step 1, open the file. Open the file to read. Step 2, open the file to write. You don't have to worry about it. Don't worry. Don't worry about it now. Okay, I've taken care of that. And again, reading step 3, reading the data into the buffer. Again, I have done it, so you don't worry about it. But you can always look into it, how I did it, but it's not needed. Now here, I got my buffer. This is what you will be doing it for other operations. Copy operation. You have to understand how this copy works, because you will be doing it for other operations. Alright, okay. And the last step is write the output buffer to the file. Again, you don't have to worry about it. I have taken care of it. You only have to worry about this copying. So we saw in this video how to open the image files, I mean, you still don't have to worry about it, but see my program. And then we copied the data and we wrote it to the file, to another file. The assignment is practice this, practice compiling and view using GIMP. Okay. By the way, the reason most of the universities in America use GIMP to view PGM files. PGM files are nobody supports nowadays, only GIMP supports it, and because this is a plain text format. If you want to know more about this, you can view Stanford University. They use a lot of assignments using PGM and GIMP. Okay. All right. So this is first assignment for you is I want you to guys tell me that everything works in next couple of days. This is not for grading, but I assume you do it. All right. The next step is, I'll show it to you now. Assignment number 2. Okay. We have the buffer. Now we are only dealing with buffers now. We are not going to deal with pictures, right? We got the data. All right. They are same size, input and output. Let's say we have something like this, a picture. Okay. I want you guys to write the line of code here where we copied, you remove this and put in the code for the second assignment. Alright, I'll write down so you guys know. This is the meat of the program. You have to worry. Alright, okay, let's go here. You have to inverse or mirror sorry, I use the wrong terminology here. Mirror reflection, mirror. That means this goes here, this pixel goes here, this pixel goes here, and this pixel goes here. And in this case, this goes here, this pixel, whatever pixel goes here, and nothing else. And the third column, first one and the last one. Then this two. You see, you just flip it vertical. Yeah, so mirror reflection. So how do you do that? Assignment number 2. All right. Assignment number 3. Assignment number 3 is easy to explain with a video than a PowerPoint. Okay. We will take probably, let's say this is a picture. Okay, this is the input buffer. Your output buffer is same as here. By the way, I'm just taking a simple example. In your case, is 99 width, 99 height, right? Okay. This is the inverse. What is inverse? All right. Let's say we have the pixel value here, a value. Remember, what did I tell you about the value? It ranges from 0 to 255. Yeah? I want you to inverse. What does the inverse means? If the value is, say, x, that means my value in the range is somewhere x, right? I want you to guys inverse to the remaining value from 255. That means 255 minus x. I want you to go in here. If this is x, I want you to write 255 minus x. If this is y, I want you to guys write 255 minus y. If this is z, I want you to write 255 minus z. So this is a simple one. Okay, you write everything either in a different file. Different file is good, so you can debug each and every program. So we have what we got. We did a copy which is given to you. Assignment 2 is mirror reflection, 3 is inverse, Anyway, the last one is okay, this is the output buffer. You are going to blur the image. Blur the image means you are going to reduce the brightness or contrast. You're going to reduce. How we are going to do that is, this is all done in imaging in the PhD work, guys. This is all work of a PhD thesis 20 years ago. A lot of people did work on this. Okay. The blurring is for every pixel that you have, right? This is the output. This is the input, right? For every pixel you have, you don't just copy that pixel in the output buffer. What you do is you take the adjacent pixel, right? This is the adjacent pixel for this. This like 1 adjacent, 2 adjacent, 3 adjacent, 4, 5, 6, 7, 8, 9. For every pixel you have 8 neighbors, right? So you are guys coming from math background, you guys know for every x comma y there are 8 neighbors. So you figure those 8 neighbors. Okay? So if I have x comma y as my pixel, I want you to guys take x minus 1 comma y, that's 1 pixel, plus x minus 1 y plus 1, that is another pixel, right? If this is x comma y, you know these coordinates, plus so these are coordinates. Right? I've written coordinates. There are 9 coordinates, right? So you know the 9 coordinates of if any x and y. You divide this, add each one of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. Add all the pixel values surrounding x comma y and divide the whole thing by 9. Okay, we have 9 elements, 1, 2, 3, 4, 5, 6. And that's what it goes here. This whole thing, expression, goes in here. Okay? Similarly for next x and y, do that. If you don't understand this, let me know. So there are 3 assignments you have. This is 4, assignment number 4. And this is probably is easier if you are coming from a math background. Let me explain it to you one more time so you guys know what I'm talking about. Okay, for every x comma y pixel there are 9 neighbors including the x comma y. Right, if this is x-axis, this is y-axis or whatever, this is x plus 1, y minus 1, and this is what? X plus 1, y plus 1, right? And what is this? X minus 1 and y. And what is this? X, y minus 1. So we have 9. You take all these pixels, divided by 9, you get the output value. And that's what goes in the output. Okay? So you have 4 assignments to do. One is copy, mirror, inverse, and then blur operation. Okay? And I have attached the code for you. Let me attach the code right here. It's compiling here. And every time you run this program, make sure you take a backup of the output file. See here. I have done a backup, blur myself, and I went at, I changed copy image. You have to change here whatever the output you want, name of the file, I mean. You can change the name of the output file whatever you want. Assignment1.pgm, assignment2.pgm, whatever it is. Okay? So you have everything here. Just follow the program and write it. Just cut and paste here, and this is where I said important for you guys, right?